Students, let's continue the basic building blocks of Hadoop topic. So in my last session, we have discussed building blocks of Hadoop. The 5 basic building blocks of Hadoop are NameNode, Data Node, Secondary NameNode, Job Tracker, Task Tracker. These are the 5 basic building blocks of Hadoop or Hadoop services or Hadoop daemons. Okay, students? Fine. In today's class, we will be discussing about the segregation of the basic building blocks of Hadoop. We have segregated those 5 into 2 groups. One is HDFS daemons group, another one is MapReduce daemons group. So today we will start with HDFS daemons. The HDFS daemons are 3: NameNode, Data Node, Secondary NameNode. The HDFS daemons are 3: NameNode, Data Node, Secondary NameNode. Okay, students, let's start with the NameNode. So as we discussed in the previous session, that is, the NameNode is a master. NameNode is actually it is a program at low level. It is a master. It acts as a master. So it runs in a master node. In the cluster, there will be one client machine, one master node, and many slave nodes. So in master machine, this NameNode will be running. There will be only one master. There will be only one master machine. In that machine, only one NameNode will be running. Okay, fine. And what does this NameNode will do? What is the task of the NameNode? So the main task of the NameNode is to monitor all the slave nodes. There will be many slave nodes in the cluster. So this master will monitor, this NameNode will monitor all the slave nodes. What does this mean? Monitoring the slave nodes in the sense, in slave nodes, the data nodes will be running. In all the slave nodes, the data nodes will be running. So the NameNode will monitor all the data nodes, whether they are working properly or not, whether they need any information or whether they need any communication. These things, this will be monitored by the NameNode. This is the first task. And the major task of the NameNode is to store metadata. This is a major task of the NameNode. What is the major task of the NameNode? If anyone asks what is the major task of the NameNode, NameNode stores the metadata. NameNode stores the metadata. So what is metadata? At high level, metadata means the data which describes about another data. The data which describes about another data is known as the metadata. So which data it will describe actually? Which data this metadata is describing? That we'll get a question, isn't it? So this NameNode maintains a metadata, meaning the data about another data. And another data is the original data. Another data is the original data. Let's say this HDFS is used for what purpose, students? HDFS is used to store large amounts of data. Large amounts of data. Let's say I'm having a file of 100 TB. I'm having a file of 100 TB. That file I'll be storing into the Hadoop. Into the Hadoop. Into the Hadoop in the sense I'll be storing that in the cluster. I'll be storing that in the group of machines actually, which I am calling it as a cluster. In the group of machines, again those will be stored in the slave machines. Those will be stored in the slave machines. In the slave machines, the data nodes will be running. In the slave machines, the data nodes will be running. So the original data, here the file data, I am calling it as a original data. This file data is stored in the data nodes. This file data is stored in the data nodes. The data nodes will be many. The data nodes will be many, like 100, 200, 300 likewise. So the file which we are speaking, that is 100 TB of file, that is splitted. Actually, that file will be divided into blocks. That file, what we are calling that 100 TB of data, will be divided into blocks, and each block will be stored in one data node. Each block is so that 100 TB of data we are dividing into blocks, and each block will be stored in one slave machine, that is in one data node. So students, the NameNode needs to maintain the information in such a way that which block is stored in which data node. Which block of the file is stored in which data node. That information the NameNode will maintain. That information I am calling it as a metadata. The NameNode stores the metadata, meaning this data describes about the original data which is stored in the data nodes. Not only the blocks, which block is stored in which data node, that information it will be maintaining. Apart from that, it also maintains what is the file name, what are the, where the replications of those blocks are stored, who has the permissions to access it. All this information we are calling it as a metadata. We are calling it as a metadata. Metadata is maintained by the name node. Put it in your mind. Metadata is maintained by the name node. The major role of the name node is to store the metadata. This data describes about the original data. The original data is stored in the data nodes, that is in the slave nodes. Actually, the original data is divided into blocks. Each block will be stored in one data node. So, which block is stored in which data node, and also we will be taking the backups, we will be taking the replicas of these blocks. Those replicas also will be storing in the data nodes only. This entire thing you will get to know when you learn HDFS architecture. At that point of time, I will be taking one example and describing everything. Just hold on, I'll just follow this session, students. Okay. The name node maintains the metadata. Okay, this is a task of the name node. There will be only one name node. That one name node will be running in the master machine. Okay. Fine. Next, let's go to next daemon, that is data node. That is data node. The name itself says data node. The node which handles the data, which handles the actual data. Okay. So this is actually, this data node is a program. It runs in the slave machines. It won't run in the master machine. It runs in the slave machines. In n number of slave machines, we can make it run actually. Okay. And what is the what actually this data node will do? This data node stores this data node stores the actual data. That is the file data which we have spoken in the previous slide, what 100 terabytes of data. That 100 terabytes of data will be stored in the data nodes. First, that 100 terabytes of data will be divided into blocks. Each block will be stored in one data node. There will be many data nodes, no? So each block of the file will be stored in each data node. Okay, so the actual data is present in the data nodes, but not in the name node. The name node maintains only the metadata. Okay, students, I have given examples. We can store 100 terabytes of data, 110 petabytes of data. It's big data actually. And this is one of the major tasks of the data node. What is the major task of the data node? It stores the actual data. That is big data. We do have another roles. Data node also handles another roles. What are those roles? It also handles two roles. The first role is it sends the block report to the name node. Name node is a master. The corresponding slave is the data node. Master is the name node. Slave is the data node. So slave will be communicating with the master. Master also communicates with the slave. Okay. So now the slave will be sending a block report to the name node. What does that mean actually? What does that block report mean actually? Whenever a data node gets a new block, in the data nodes we will be storing the blocks, isn't it? The file is divided into blocks. Each block will be stored in each data node. That block, whenever a data node stores a new block in it, whenever a data node gets a new block in it or stores a new block in it, immediately the data node will send a report, will send a block report. Because why it has given the block report, the name as block report means it is storing the block in itself and it is passing the information to the name node saying that, hey name node, I got some new blocks to store in me. I have stored in me. You just update your metadata. In such a way, this report will be sent by the data node to the name node. Okay. Whenever a name node gets a block report from the data node, it updates its metadata. It updates its metadata. The new block is stored in the data node. So which data node is having which block needs to be written in the metadata. So whenever a data node sends a block report to the name node immediately updates the metadata. So and so data node holds so and so block. In such a way, it updates the metadata. And it sends a heartbeat signal to the name node. What does this heartbeat signal mean? Students, how can we say that we are alive? through our heartbeat signal, isn't it? In the same manner, how come the master knows that its corresponding slaves are alive, that is, it's working properly? The master needs to know that information. The master needs to know that all its slaves are working properly, all its slaves are alive. For that sake, in order to fulfill that requirement, the data node will be sending a heartbeat signal to the name node. This heartbeat signal represents that the data node is alive. It is working properly. It is functioning properly. Every data node will send a heartbeat signal to the name node saying that I am alive. Okay, two communications will be done from the data node to the name node. The first communication is the data node sends a block report to the name node whenever it stores a new block in it. The second one is for every 30 seconds the data node needs to send a heartbeat signal to the name node saying that I am alive. If any data node is failed to send a heartbeat signal to the name node, the name node assumes that that particular data node got failed. Accordingly, it will take an action. Accordingly, the master will take an action. Okay, students? Fine. So we have discussed two daemons, two HDFS daemons. One is name node, another one is data node. Name node is the master, data node is the slave. The name node maintains metadata, data node stores the actual data. Okay, fine. So the next one is secondary name node. The next one is secondary name node. Everyone will think that as the name specifies a secondary name node, maybe it might be the backup of the name node. It might be the backup of the name. Usually people will think that this daemon is the backup of the name node. But students, this daemon is not the backup of the name node. Secondary name node is not the backup, is not the replication of the name node. It just helps the name node in order to do one task. The secondary name node will help the name node to fulfill one task. We'll see what is that task. Okay, make sure, put it in your mind that secondary name node is not the backup of the name node. It's just a helper node to the name node. Okay, fine. So students, as I said, it is a helper node. It won't run in the master machine. I said that in the cluster there will be one client machine, one master machine and many slave machines. In master, the name node will get run, and this secondary name node will be running in one of the machine in the cluster, but not in the name node, but not in the master machine, Make sure that the secondary name node is not working in the master machine, because in the master only name node and job tracker will be running. We will see the job tracker in the next slide. Okay, in the master machine only the name node and job tracker should run, but not the secondary name node. Okay, students, fine. So what is the role of secondary name node? What kind of help it will do to the name node? We will see that. Students, as I said, like in the previous slides, we have discussed that the name node maintains the metadata. Name node maintains the metadata. Metadata describes about the original data, which block is stored in which data node. That information is held by the name node, isn't it? So students, the name node will maintain this metadata in a file called fs image. The name node maintains the metadata in a file called fs image file. Fs is very important for the interview. In which file the name node maintains its metadata. The name node maintains its metadata in a file called fs image. Fs stands for file system. Fs stands for file system image. Fs image means file system image. In this file, the name node will maintain its metadata. Okay, fine. Students, the name node also maintains one more file called edits log. The name node maintains one more file called edits log. It's a log file. You people know what is log file and all, isn't it? Whatever the operations actually happening in the cluster, will be logged into the edits log file first. Whatever the operations happening in the cluster, that will be stored in the edits logs file instead of moving to the fs image directly. In the sense, the metadata which we are speaking, initially what the blocks will be stored in the data nodes. So which block is stored in which data? All these are the operations, isn't it? Those operations will be stored in the log file first. After some time, this information will be moved to the FS image file. The log file data will be moved to the FS image file. This movement, the data from log file to FS image file, this movement, this copying will be done by the secondary name node. Will be done by the secondary name. The name node won't do this task. The name node won't do this task. The name node just monitors all the slave nodes and it stores the metadata. That's all. Okay. Initially the metadata will be in the FS image file, but after that, once the metadata is in the FS image file, later in the cluster some operations will be going on. No, those operations first will be putting it in the log files. After certain checkpoint, we will be updating those log data into the FS image file. Okay, that updation, that copying will be done by the secondary name node. The secondary name node, for every 1 hour or 2 hours, whatever the timing, we can fix the timing. For every 1 hour, the secondary name node will request the name node. The secondary name node will request the name node for the edit log file and for the FS image file. For the edit logs files and for the FS image file, it will get those two files. The secondary name node will request the name node for these two files. It gets those two files, it stores in it, and it will copy the recent log file data into the FS. It merges, actually the correct word is merging. The edit log data will be merged to the previous FS image file data. After merging, this FS image file will be again given back to the name node by the secondary name node. This will be done periodically. Periodically in the sense, either for 1 hour or 2 hours. Likewise, the FS image file will get merged with the log file. Once the secondary name node merges the log data to the FS image file, the log file will get refreshed. The log file will be refreshed, meaning the data in it won't be there. It will be deleted. A fresh edit log file will be there with the name node now. Why the secondary name node is doing all these things? Can't the name node will, the name node can do these things, like copying this edit log file into the FS image file. In order to not to make so much of burden to the master, this task is given to the secondary name node. This task is given to the secondary name node. Secondary name node will perform the merging of the edit log files to the FS image file, and the updated FS image file will be sent to the name node. For that purpose, secondary name node will come into the picture. Okay, students, and whenever a name node got failed, whenever that master machines got crashed, the secondary name node will be holding the FS image file. The secondary name node will be holding the FS image file that can act as a backup metadata. But since, students, there is a flaw in this, there is a problem in this actually. What is that problem is, for example, I am a secondary name node. After 1 hour, I'll be taking the FS image file as well as the edit log file from the name node. I'll be merging those two. So the FS image file is updated now. Every operation is stored in the metadata is stored in the FS image file. That FS image file I have given to the name node. I am having FS image file currently with me, and also shared one copy to the name node. Okay. This happened now at this point of time. After half an hour or after 45 minutes, the name node got failed. Assume the name node got failed. Okay, within the span of 45 minutes, some operations will be held in the cluster, isn't it? Some operations will be done in the cluster. Those operations is listed in the file called edits log. Edits log file will be with the metadata. So, if I take my FS image file is not an updated one, because those edit log files data is not updated in my FS image file. Though I can take I can give that FS image file as a backup to the master, but it is not the one which is accurately updated. That is a problem. So we are not calling secondary name node as the backup of the name node. It is just a helper. It cannot take all the, what can we say? It won't take all the primary functionality of the NameNode. It won't take all the primary functionality of the NameNode. Okay, students? NameNode, data node, secondary NameNode. NameNode stores metadata. Data node stores actual data. Secondary NameNode merges FS image file and edit log file. It is a helper node to the NameNode. Okay, fine. So the next one is, we have done with the HDFS daemons. HDFS daemons are 3. NameNode, data node, secondary NameNode. Now the MapReduce daemons. MapReduce daemons are 2. What are those 2, students? One is job tracker, another one is task tracker. Okay, so let's start with the job tracker. Job tracker is a master. Job tracker program is a master program, meaning it runs in the master node. Already one master is running in the master node. Who is the NameNode? In the same machine, we usually run the job tracker also. Job tracker is a program node, so the program will be running. Where it is running in the master machine. NameNode and job tracker will be running in the master machine. NameNode is a master for HDFS. Job tracker is a master for MapReduce. And what is the role of this job tracker? What is the role of this job tracker? As this is a master, it monitors all its slaves. Who are the slaves of the job tracker? Task tracker is the slave of the job tracker. We have seen in the previous session. Task tracker is the slave for the job tracker. So it monitors all the task trackers, whether they are working correctly or not, whether they are receiving correct information. All these things will be monitored by the job tracker. So what does this job tracker will do actually? This is one task. It also do some other tasks. What are those tasks? We will define now. So students, this particular daemon, this particular program, job tracker, the name itself says that it will track the job. It will track the job. It won't execute the job. Make sure the job tracker won't execute the job. Job in the sense, which job? A MapReduce job. A MapReduce job. They will be, this daemon is used for processing the data. Processing the data. The data is already stored in the cluster by whom? By the HDFS daemons. Already the data is stored in the cluster. Actually, the data is residing in the data nodes. Okay. Now, after storing the data, what is the next step we usually do? Process the data. We will be retrieving some useful information from that data. For that, we will be writing some jobs. Those are called as MapReduce jobs. Okay, students. So, as a programmer, whenever I write any MapReduce job in order to process the big data, that job will be directly, the user will submit that code or that job to the client machine. The client machine will in turn send this code to the job tracker. Once again, I am telling students, assume I have successfully stored the data into HDFS. After storing, what we usually do? We process the data. To process the data, we will be writing some code. That I am calling it as a job, MapReduce job. Here I will be writing the code I will be writing the code using MapReduce programming model. So I am calling that as a MapReduce job. Whenever I write any MapReduce job as a user, I will be submitting it to the client machine. The client machine will in turn send that code to the job tracker. Who is the correct person to handle that request? The job tracker is the correct person. So the job tracker will take that MapReduce code, will take that MapReduce job or MapReduce task, and it won't execute that because it is a master. Master won't do such kind of things. Actually, the person who actually executes this job is task tracker. Who will execute the MapReduce job? The task tracker will execute the MapReduce job. So what the job tracker will do is it takes that code and it interacts with the NameNode. It communicates with the NameNode. For what purpose it needs to communicate with the NameNode? Why should it communicate with the NameNode? Isn't it? What is the need of communicating with the NameNode? Because whatever the code I have written, that code will process which data? The data which is already stored in the cluster. Who already stored the data? The data is stored in the data nodes. But which data node is having which block? That information is stored with the NameNode. So only the job tracker will interact with the NameNode for data locations. Where does the data which I require is stored? You just send me the data locations or IP address of those data nodes. So immediately the NameNode will respond, and it will send the data which this MapReduce needs to, where this map, the NameNode will send the IP addresses of the data nodes where the data actually residing. Once the job tracker gets that information, now it is having both MapReduce program as well as the data location where the data is actually residing. On this data, this program is good. Whenever we write any program, we need to give the input. No, I will be sending the input data as the input to the program. Here in this case, the usual traditional programming, like in usual traditional programming languages, students, if you observe, we will be sending the input data towards the program, isn't it? Writing the program, while executing the program, it will ask the input, will be sending the data, input data to the program. But here in this case, this is different. We'll be sending the data, we'll be sending the program towards the data, but not data towards the program. Very, very, very important one. We are not sending the data towards the program, but we are sending the program towards the data. Where the data is residing in the data nodes. That information is maintained by the NameNode. So only the job tracker will interact with the NameNode for data locations. Once it gets the data locations, now the job tracker will send this code to all the data nodes where the actual data is residing, to all the slave nodes. Once that code is reached to the slave nodes, one more program will be running. That program is called as task tracker. In the data nodes, in the slave machines, along with the data node, task tracker will also be running. Data node as well as task tracker will be running. Now the task tracker will trigger and receive that MapReduce job, whichever sent by the job tracker. The task tracker will receive the MapReduce job, and it is a responsible person to execute the MapReduce job by interacting with the data node. The task tracker will interact with the data node because data node is having the actual data. So on that data only this MapReduce program needs to execute. So only the task tracker will interact with the data node. So slave communication. We have seen the communication part now. Master will communicate. Slaves will also communicate. Job tracker communicated with the NameNode. Now the task tracker is communicating with the data node. Understand, students? The job tracker will interact with the task tracker for the execution of the MapReduce job. And the job tracker also takes care of the failures of the task trackers because it needs to monitor all the slave nodes. No? Whenever the task tracker got failed, it needs to take an appropriate action. What are those actions? We will see in the next sessions. Okay, students? The job tracker, the main role of job tracker is to track the MapReduce job, whether the particular MapReduce job is executing or not. For that, it will get some information from the NameNode. It will pass that information to the task tracker. Along with that information, it also sends the MapReduce job. Task tracker will execute that job. And next one is task tracker. We have discussed till now the task tracker as well, but combinedly I have discussed. But again, one more, I'll be summarizing it. It is we know that it runs in the slave nodes along with the data nodes. The main task of this task tracker is to execute the MapReduce job, to execute the MapReduce tasks, and it also communicates with the data node for the actual data where this map and reduce task needs to be executed. This is a major role of the task tracker. And again, the task tracker also sends a heartbeat signal to the job tracker saying that I am alive. Job tracker is a master. Task tracker is the slave. So job tracker needs to know whether the task tracker is running or not. For that sake, the task tracker for every 30 seconds, it needs to send a heartbeat signal to the job tracker. If the job tracker does not receive any heartbeat signal from the task tracker, it assumes that the particular task tracker got failed. So accordingly, it will take an appropriate action. Okay, students? So I have given the MapReduce daemons picture here. there will be one master, there will be many slaves. The master is job tracker. It spans the MapReduce job. Task tracker will actually execute the MapReduce task by interacting, by communicating with the data node. Here one more picture I have given here. I have included both HDFS daemons as well as MapReduce daemons. In HDFS layer, if you see, I have defined two layers here. HDFS layer as well as MapReduce layer. In HDFS layer, NameNode data nodes are there. In HDFS layer, NameNode data nodes are there. In MapReduce layer, job tracker and task trackers are there. If you observe deeply, students, data node, task tracker running in the same machine. I have specified two machines here, two slave machines. The two slave machines, data node as well as task tracker, both are running. Similarly, in the master machine, both job tracker as well as NameNode are running. Okay, students. So this is the entire basic building blocks of Hadoop concept. I will be summarizing, students. There are 5 basic building blocks of Hadoop. NameNode, data node, secondary NameNode, job tracker, task tracker. The first 3, NameNode, data node and secondary NameNode, are HDFS daemons. The last 2, job tracker, task tracker, are MapReduce daemons. The first part, that is the first group, that is NameNode, data node, secondary NameNode, is for storing the data. Job tracker, task tracker is to process the data, to execute a MapReduce job. Okay, students? Thank you. Have a nice day.